Our next problem was coming from circles. This number was coming from circles, and that was number 7. So now, it says in the diagram below, O is the center and angle B is 55. Calculate the size of angles marked X and Y. So this is X and this is Y. I want to get the size of those angles. So this is the obvious property, the easiest property, which says that angles at the center are twice angles at the circumference. So now there, my X was going to be, so this X is going to be twice the angle 55. And so our X was 110 degrees. That was very easy. Then if we're going to get Y, we use the property of cyclic quadrature, that these two opposite angles, they add up to 180 degrees. So now there I say Y plus 55, they will add up to 180 degrees, and so my Y will be 125 degrees. Alternatively, someone can use to get Y and say, now this angle, what will be the balance? You can get the balance because you know this 110, then you can get the balance of this one here. So now you say, now the balance here. So you see that now the balance here, my 2y will be, what will be my balance? If now you say, if this is now 125, you subtract from this to get the balance, then you'll be getting your y with ease. Okay. Now from there, we shall move to, now the next number, it will be now our 2y. What I'm saying, our 2y will be now 360 minus 110x. So my 2y will be, when you subtract there, what do we get? We get, is it 200? Sorry, here I get 250. So my y, when you divide there, I think you get 125 degrees. So that is the alternative I was talking about. Okay, now this one was coming from matrices, which was saying find the inverse of m. In order to get the inverse, we need the determinant and the adjoint. So now, in my solution, I get the determinant of m, which is going to be then minus, and this was giving me, this will be negative 10 plus 12, and so our determinant was 2. Then we come for our adjoint, which will be, we interchange elements in the major, we interchange, then we change the signs, or we multiply them by negative 1. So multiply by negative 1, you get 6. By negative 1, you get negative 2. So now, our inverse of m is going to be 1 over 2 times the adjoint, which will give us now, then this will give us negative 1, 3, 1. And so that is how it's supposed to get the inverse with ease. Then this one was coming from linear programming, the inequalities specifically. So you see, I want us to determine the inequality which represents the unshaded region on the graph below. So we start by getting the equation of this line. We have the intercept already, but now we need to get the gradient. So how do you get the gradient? So to get now my gradient, if I have 2 points, I'll say y2. Now my y2 is going to be 3 minus 0 over 0 minus 3, which will get me to negative 1. And from my y equals to mx plus c, if I have the gradient, I have the intercept, my intercept here. My c is going to be 3. From there, the intercept, y-axis intercept. So now my y will be negative x plus 3. So that is the equation of the line. But now we want to get the inequality it represents. So now if I choose this point here, this point is 1, 1. If I choose now the test point as 1, 1, and I use this, I'll be having now, this is, remember this is my x, this is my y, so I have 1 then negative 1 plus 3, which is 1, 2. Which sign is that? 1 is what? 1 is less than 2. So meaning, now therefore my inequality, mean that this is now the wanted region. So it's the unshaded. I got this point from the unshaded. The inequality that satisfies there is this. And now, so I have now y less negative x plus 3. What is missing? I come and I check the nature of the line. Now because this line is solid, so this one had to be less or equal to. And so that's why we are supposed to get our inequality. If it was broken, then it would have been the less. So the inequality which represents the unshaded region, which is this one, is this. And that was that. That's it. Members, let us go to the next number.